I don't know. All right, so let's begin today's session. Uh, Let me start with my introduction. So I'm Jeetendra Dixit. Here's my profile. So I did my graduation from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. Today we'll do continuity, and before we begin, let me tell you about the Unacademy subscription first of all. In this channel, this is a channel of, English. So I think on this channel, nobody would be teaching you in Hindi. Oh, all right. I don't know about that. Okay, all right. So you can take plus subscription, and if you take plus subscription, then you'll get access to daily live classes of all the educators uh, on the platform. You can attend their live sessions as well as recorded sessions. You will also get access to live classes of live tests and quizzes, and these are the subscription charges. So for 12 months it is 38,500, and for 12 months after 10% discount you'll have to pay only 34,650. For 24 months it is 56,000. Acha, okay, I'll talk to you, no problem. Yeah, for 24 months it is 56,000, and after 10% discount you'll have to pay 50,400. Now this is iconic subscription in which you'll get all the benefits of plus, and apart from that, a personal coach who will guide you throughout your preparation for top exams. Your test analysis will be done in a personalized manner, and your study planners will also be customized, all right? And bi-weekly reviews will be given to you to highlight your progress. Now these are the subscription charges for iconic: 56,000 for 1 year, and after 10% discount it will be 50,400. Similarly for 2 years, 2 years it is 86,000, and after 10% discount. Hello Subshri. Unacademy learning app. How to improve maths? Maths कैसे strong करूं? Maths practice से strong करोगे. Okay. So that is the only way. Learn some basics and then practice questions. Like if you want to strong calculus, then you'll have to work on the fundamentals of calculus. Like you'll have to work on functions. Okay. So अगर calculus strong करनी है तो functions पे काम करो सबसे ज़्यादा. Similarly, if you want to strong your coordinate geometry, then work on geometry. Okay, because geometry बहुत ज़्यादा involve होती है coordinate geometry में, and rest equations वगैरह काफ़ी चीज़ें memorize भी करनी होती हैं coordinate में. And algebra is difficult compared to calculus, and so algebra generally उन लोगों का strong होता है those who are working in maths for a long time. Like they have started working with maths in class 8th and 9th. वहाँ पे काफ़ी अच्छे से identities and everything they have done. Raghav, you're saying, sir, will you be teaching full limits, continuity, and differentiability? And sir, I watched your recorded videos, so should I start solving now? Yes. I'll finish this continuity and differentiability at least, yeah. Continuity, today I'm starting continuity, and then I'll finish it properly. Okay. So guys, you can download this Unacademy's learning app from Play Store and start attending special classes. The special classes are completely free. Okay, so let's begin the session today. Okay, so the first very important point is fx is said to be continuous at a point A. So we are checking the continuity of a function at a particular point. At point x is equal to A. You can say x is equal to A. At a point x is equal to A. If limit x approaching to A, f of x is equal to, first of all, limit does exist. That means left hand limit is equal to right hand limit, and that is limit of fx when x approaches A should be equal to f of A. Okay, so value of f of A is now important. Okay, so if left hand limit is equal to right hand limit is equal to value of the function, then function is said to be continuous at x is equal to A. Okay, or you can say left hand limit of fx at x is equal to A is equal to right hand limit at x is equal to A is equal to f of A. Then function is said to be continuous at x is equal to A. Now there are two terms are there, left continuous and right continuous at some point. So what is this left continuous and right continuous? I'll tell you. This is if this holds, left hand limit is equal to right hand limit is equal to value of the function. It's like this. If graph of a function, if function is continuous, then its graph will not be broken at any point. मतलब पेन पेपर का कहीं पे भी contact lose नहीं होगा if you are plotting the graph of y is equal to fx. All right, then like this is a continuous function, graph of a continuous function. Okay, if you're checking the continuity at some point, say this is the point, this is x is equal to A, then this is f of A, you can see, and left hand limit is this, left hand limit is approaching to the same point, and right hand limit is also approaching to the same point. So first we are understanding the condition of continuity at any point. Then we will learn the types of discontinuity. If it is discontinuous, then which type of discontinuity? There are types of different types of discontinuities. Okay, so first let me tell you one word, left continuous. Okay, left continuous at x is equal to A. So f is said to be left continuous. F is said to be left continuous at x is equal to A if f left hand limit, you can say left hand limit is equal to f of A. So what is left hand limit? How do we write left hand limit? F of A minus h, right? F of A minus h when h is approaching to 0 should be equal to f of A. All right, so that is called left continuous. All right, so sometimes it might be mentioned in the option that function is left continuous but not continuous. Not continuous means right hand limit might be different. Okay, so even if left hand limit is equal to value of the function, then you can call it left continuous. All right, similarly there's a word right continuous. Right continuous means similarly you can write f is said to be right continuous at x is equal to A if right hand limit is equal to f of A. Okay, that means f of A plus h approaching to 0 is equal to f of A. Okay, so these are the terms. Okay, this is the condition for continuity at x is equal to A. This is the condition for left continuous at x is equal to A. This is the condition for right continuous at x is equal to A. Now let's do some examples to understand it. So I'll give you some very standard examples to understand the situation. See, we have y is equal to greatest integer of x. All right, let's see which type of continuity is had at integers. Okay, at any integer, choose any integer. So check the continuity at integers. All right, so obviously we know the graph of greatest linear function, right? This is like stepwise function. It's like this, right? Graph of this function. say this is your x-axis. If this line is your x-axis, you can see this will be 0. This is 1, this is 2, this is 3, this is 4. So obviously it is not continuous, right? So discontinuous at all integers. Now let's check left continuity or right continuity. Whether this function is left continuous or right continuous at x is equal to, say, 1. Let's check at 1, okay? So at x is equal to 1, f of 1 is equal to what? 1, right? Greatest integer of 1 is 1. And f of 1 plus h, right? So that is greatest integer of 1 plus h. H is approaching to 0. So that is also 1, right? You can see this is the right hand limit. So right hand limit is equal to value of the function. But left hand limit is different, right? Left hand limit you can see is 0. So left hand limit is 0. So left hand limit, there is right hand limit. If you want to calculate left hand limit, then left hand limit is going to be f of 1 minus h, h approaching to 0. That is greatest integer of 1 minus h, and it is going to be 0, right? So you can see these two are equal. Because all three are not equal, so we'll say function is not continuous at x is equal to 1. And similarly at 2, similarly at 3, similarly at 4, right? So at all the integers. But it is left continuous at x is equal to 1. Sorry, right continuous at x is equal to 1, not left. Because right hand limit is equal to value of the function. So f is right continuous at all integers. Have you got this point? ये वाला point समझ आया? Now let's see another example. So you have y is equal to fractional part of x, right? We know this function and we need to check at integers. So we know in this case also fractional part is discontinuous function. We know the graph of fractional part of x. Just let's see whether it is left or right continuous at integers, okay? So we are going to check that left and right continuity. Obviously it is discontinuous because graph is broken, right? You can see discontinuities. So through graph we can see the discontinuities, right? So say this point is 0, this point is 1, this point is 2, and this point is -1, -2. So let's check at x is equal to 1, okay? Or you can choose any integer. You can take n also. So f of 1 is going to be fractional part of 1. That is going to be 0, right? Fractional part of integer is 0. Now if you take fractional right hand limit, so right hand limit is 1 plus h, and that is going to be fractional part of 1 plus h, and fractional part of 1 plus h is h only, right? So that is also 0, right? And if you take left hand limit is f of 1 minus h, and fractional part of 1 minus h is, because 1 minus h is slightly smaller than 1, so it is already a fraction, so its fractional part will be equal to 1 minus h only, and h is approaching to 0, so it is 1. So left hand limit is different. Right hand limit and value of the function, these two are equal, right? You can see in graph also, you can see this is value of the function at 1, and this is right hand limit, which is close to 0, approaching to 0, and left hand limit is here, it is approaching to 1. Yeah, I'm just discussing the points, what is left continuity and what is right continuity, okay? So after this I'll take some examples where functions will not be standard, okay? I'll have to check it properly. Now I'll give you one example. Example 3. Now suppose function fx is defined like this. X raised to n sine of 1 upon x, all right, when x is not equal to 0, and 0 when x is equal to 0, okay? This is continuous. Okay, wait a minute. I'll come to this example later after this. First, you need to check this. Under root of x, sine of 1 upon x is not equal to 0, and 0 when x is equal to 0. Now you need to check the continuity of this function, okay? Check the continuity. Of fx at x is equal to 0 only. And anyways, other than 0, there's no problem at all. Wait a minute. I'm putting mod here, okay? Mod of x, under root of mod of x. Yeah. True, it's continuous. Why? Because when x approaches to 0, from left or right, doesn't matter, because now we have mod. So this function is approaching to 0, and sine of 1 upon x, this is sine of infinity, and it will always be between -1 and 1, right? This function. So some number, yes, it is 0, and at x is equal to 0, f of 0 is given 0. So yes, this function is continuous. Good. True. Now let me give you another example. Fx is equal to now check the continuity of this function. It's a similar example. I just want to check your knowledge. And this is 0 when x is equal to 0. Check the continuity at x is equal to 0. Continuity, okay? Try this one. This is example 3. This is example 4, okay? So third, you are saying third is not continuous? Third is not continuous? Raghav? Who else will answer? Why it is not continuous? Huh? What is the problem? See, sine when x approaches to when x approaches to 0, so sine 1 upon x belongs to -1 to 1, right? It is a fluctuating function. It will be anywhere between -1 and 1. You can't predict, because when x approaches to 0, 1 upon x approaches to either plus infinity or minus infinity, and infinity is not a fixed point, it is a large interval, right? So it will be a fluctuating function, but you are multiplying this function by ln of 1 plus x, which when x approaches to 0 only, right? See, put x is equal to 0 in this, it is ln 1. Okay. So like in the previous question, you multiplied it by root x, okay? And what was the job of root of x? Root of x was approaching to 0, and it was multiplied to sine 1 upon x, and it made this whole value is equal to 0. Okay, because you multiplied sine 1 upon x to a function which was approaching to 0. Here also you are doing the same thing. You are multiplying sine 1 upon x to a function which is approaching to 0. So it will make the value 0, right? So This implies that ln of 1 plus x sine 1 upon x. This is a finite number anyways, right? Although it's fluctuating, but it is between two finite numbers, so it's a finite number multiplied to 0. So when x approaches to 0, this function is approaching to 0 only, right? So limit is 0, value is 0, so function is continuous, right? You can multiply sine 1 upon x to any function. You can multiply it by sine x also. You can write sine x, you can write tan x, all right? You have infinite options, okay? All right, good. Now example 4, try that. Okay, so I'm creating some space. I'm removing this option. Okay, not continuous. Oh, what has happened? What is the left hand limit? What is the right hand limit? And what is the value is given 0. You just need to calculate left hand limit and right hand limit. So you're not getting same values, huh? Left and right limit. Let's check. Okay, so when x, let's check left hand limit, okay? So left hand limit, when x is approaching to 0 minus, okay, put 0 minus h basically, okay? Put 0 minus h. So h approaching to 0. It is h approaching to 0. H is always a positive number, right? 2 raised to 1 upon 0 minus h, like this, okay? Now it is going to be h approaching to 0, 2 raised to minus 1 upon h, right? Okay, so 1 upon h is basically infinity because h is approaching to 0 and h is a positive number. And because of this minus sign, it will be minus infinity to 2 raised to minus infinity. Are you getting this point? 2 raised to minus infinity. And 2 raised to minus infinity is what? What is 2 raised to minus infinity? 1 upon 2 raised to infinity. 2 raised to infinity is a very large number, so 1 upon 2 raised to infinity will approach to 0. So left hand limit is coming out to be 0. Are you getting this point? Now second, right hand limit. Okay, so right hand limit, you need to calculate from this function. Put 0 plus h in this. So h is approaching to 0. 2 raised to minus 1 upon, minus is already there. You need to put 0 plus h, okay, in place of x. We'll get this. And after this, it's the same question. 3. Okay, all right, 3. So h is the, it is 3 raised to minus 1 upon h. Again, it will be 3 raised to minus infinity, same as above. And 3 raised to minus infinity is 1 upon 3 raised to infinity. And 1 upon 3 raised to infinity is approaching to 0. So right hand limit is also 0. Getting it? And value of the function f of 0, that is also given 0. Hence fx is continuous. Need a good practice. Just stay with me and you will get a lot of good questions. All right, let's check again another function. So fx is equal to, it's all right. We'll do a lot of good questions. It is, let me rewrite it properly. It is 2 raised to minus of 2 raised to 1 upon x square, okay? Like this, when x is not equal to 0. And k when x is equal to 0. Check if, okay, can fx be continuous at x is equal to 0 for some value of k? If yes, then find k. Okay, so now that is the question. So where have you heard that, Raghav? Who told you? Are you in Fit G? Okay, gravity. All right, all right. Now try this sum. Try this sum and apply the concept which I have told you in previous question, okay? Now it should not be wrong. K is equal to 0. Very nice. True. So when x approaches to 0, all right, so because this function is an even function, can you see that? Whether you put plus h in this or minus h, you'll get the same value because of x square, right? So when x approaches to 0, you can see it is 2 raised to minus of 2 raised to 1 upon 0 plus or 0 minus, it is going to be infinity only. And 2 raised to infinity is infinity. And because of this sign, minus sign, it will become minus infinity. And my 2 raised to minus infinity is 0. All right, as we did earlier. So now k is equal to 0. Yeah, true. So k is equal to 0 is the value. Okay. So it was a good example. Now let's do another question. Okay, so if f function f is continuous at x is equal to 0, okay, then find k and a, okay. Now that is the question. If f function is continuous at x is equal to 0, then you need to find the value of k as well as a, okay, two values. Oh, so fast. Very nice, Raghav. Have you watched those videos in which I taught standard limits? Hmm? Okay, great. So tan of 2x upon x, you need to multiply and divide it by 2. And if you have seen the videos, then you must be knowing that when x approaches to 0 plus or 0 minus, okay, both sides basically, it is 1 plus, right? Slightly more than 1, which you can write 1 plus delta as well. So when you multiply 1 plus slightly more than 1 to 2, then it is going to be 2 plus, okay, and 2 plus greatest in here is 2. So left hand limit we are getting 2, left hand limit, okay. So left handed limit is 2, so value of the function must be 2, so k is 2. And now let's find right hand limit. So you know sine inverse of x upon x is also 1 plus, all right, 1 plus. So that a should be a into this is going to be x approaching to 0 minus. So whether x approaches to 0 plus or 0 minus, okay, from both sides sine inverse x upon x is 1 plus. So it is a into 1 plus greatest in here, and 1 plus means it is going to be 1, and then it will be a, okay. So a must be equal to left hand limit and value of the function, so a is also 2. Right, good. Then let me check it once. I'll give you one more example, okay. Let me check if you have understood it properly. So the next one is e raised to 2x minus 1 divided by x when x is less than 0, a when x is equal to 0, and oh, I need to take greatest end here of this. Greatest end here of this, okay? Greatest end here. And the right hand side it is tan inverse of x upon x greatest integer plus b when x is more than 0. Now try this. A is equal to sin LHL is 2. LHL you are getting 2. Alright. Let's see. Tan inverse x upon x greatest interior is 0. That is correct. Okay. So right hand limit you have calculated correctly. Right hand limit when x approaching to 0 plus or 0 minus. In fact, both sides this tan inverse of x upon x plus b is there. So this number is 1 minus. Okay. So that you remember correctly. 1 minus and greatest interior of 1 minus is 0. So 0 plus b. Okay. So 0 plus b means b. So your right hand limit is 0, b. And value is a. So a is equal to b. We have got this equation. Now let's see left hand limit. Okay. So left hand limit. In left hand limit, you need to do x approaching to x approaching to or you can write x approaching to 0 minus. First of all, this is going to be e raised to 2x minus 1 divided by, make it 2x, multiply and divide by 2. Second, now look at this carefully. In second step, okay, in second step, put because it was 0 minus, so put minus h first of all. Okay, so it is going to be h approaching to 0. Now it will be e raised to minus 2h minus 1 divided by minus 2h. All right, even you can put 2x is equal to h, doesn't matter. So now you need to calculate left hand limit. Do you remember that e raised to x minus 1 upon x, right hand limit of this is actually 1 plus, and left hand limit e raised to x minus 1 upon x, when x approaches to 0 from left hand side, this approaches to 1 from left hand side. Like in sin x upon x, it is 1 minus from both sides. In tan x upon x, it is 1 plus from both sides. Okay. In tan inverse x upon x, it is 1 minus from both sides. In sin inverse x upon x, it is 1 plus from both sides. But in e raised to x minus 1 upon x, it is 1 plus when x approaches to 0 from right side, and 1 minus when x approaches to 0 from left side. Do you remember that? Okay, I mentioned that in the question through graph. Okay, if you have seen the graph, it was like this, right? So right side it was 1 plus and left side it was 1 minus. Okay, so left hand limit you are calculating, so it will be 1 minus, and 1 minus is going to be, now it is 2 into 1 minus mean 1 minus delta. 1 minus delta. Delta is very small, you can say delta is approaching to 0, right? Something like that. Then you can write 2 minus delta, and greatest interior of 2 minus delta is what? 1, because it's slightly lower than 2, right? Slightly less than 2, so it is 1. So left hand limit is actually 1. So you'll get a is equal to b is equal to 1. Okay, and I'm telling you, most of the students will do it wrong. Okay, most of the students will do it wrong. They will get 2 only. All right, so this was the, now we are good with this. Okay, now next we are doing the types of discontinuities. Okay, types of. So types of discontinuities, first is, see, we have two types first of all. One type is called removable and other type is called non-removable. Okay, removable and non-removable. Okay, so these two types we first discuss. Now in removable, again you have like in removable category, we'll have certain types of discontinuities which will categorize further, and in irremovable also you'll have certain types of discontinuities in which we are further going to categorize. So first let's discuss what is removable. Okay, see, in removable there are two types. Okay, first is missing point discontinuity, and second is isolated point. First of all, in removable, what is the condition to understand this removable? Both have same condition. F of a plus h approaching to 0, which is right hand limit, should be equal to f of a minus h when h is approaching to 0, and should be finite as well, because infinity also, no, they say limit does exist, right? So is equal to finite. So if left hand limit is equal to right hand limit is equal to some finite number, then we say that that function has removable type of discontinuity. Now what is this missing point and isolated point? See, if left hand limit, I'll draw the graph of fx. See, this is fx, okay, and this is the point at which we are discussing the discontinuity. X is equal to a. Okay, so at x is equal to a, value of the function is somewhere either above or below this graph. I mean, left hand limit or right hand limit are equal. You can see left and right limits are approaching to the same point, but the value at that point is somewhere else. Okay, it might be greater than the limit or the less than the limit. So this is called missing point. Okay, missing point. This is missing point. So if I write the condition for missing point, then it is left hand limit is equal to right hand limit. Okay, that is the condition for removable type. Should not be equal to f of a. Okay, should not be equal to f of a, and these two must be finite. Remember that these two must be finite. Left hand limit and right hand limit, these two are equal and finite, but they are not equal to value of the function. Okay, but value of the function is also finite. So that is very important point. All three should be finite. Okay, but left hand limit or right hand. Okay, I'll repeat it. See, what happens in missing point, the value of the function is defined, it is finite. Value of the function at x is equal to a is finite, but it is not equal to the limit. Simple. Because limit does exist. Limit does exist in removable type, whether it is missing or isolated. Okay, whether it is missing or isolated. See, it's very simple to understand through graph. If this is the graph, okay, say this is the graph of some function, okay, and this is the point x is equal to a. This function has a hole at x is equal to a. You can see this gap, right? That means x is equal to a, we have not defined so far. Okay, if f of a is at this point only, if I fill this circle, open circle, that means function will become continuous. But if this value we need to define, but it should be somewhere else. Suppose it is above, okay, this graph, right? So now you can see left hand limit is here. Okay, I'll make y-axis also. You can see left hand limit and right hand limit both are approaching to this point. Okay, but value of function is f of a is somewhere else. So limit x approaching to a, f of x is basically L, but f of a is not equal to L, right? And both are finite. Limit is finite and f of a are finite. F of a is finite. F of A and L both are finite. Limit is finite and f of A is finite, but they are unequal. This is called missing. This is called, I'm sorry, this is not missing point. I'm sorry. This is isolated point. I was naming it wrongly. Sorry. This was isolated point. Sorry for this. This was isolated point. Okay. This point is isolated from the graph. It is somewhere else. Okay. It is somewhere else. So it's isolated from the graph. You can see that. Missing point. Now let me tell you missing point. So missing point is this. Missing point is function has missing point discontinuity when f of a plus h, that is right hand limit, h approaching to 0, is equal to f of a minus h. That should be the condition, right? That is the condition of removable discontinuity, and these both missing and isolated are removable, so obviously left hand limit will be equal to right hand limit and finite. Both will be finite. And f of a is not defined. F of a is not there. F of a is not defined at all. Okay, so that is called missing point. It's like this. This is the graph. Okay, so at x is equal to a, you can see there's no value. There's completely missing, right? I'll give you example after this. First you understand it through graph. Is that okay? You can see left hand limit is equal to right hand limit. Left hand limit is equal to right hand limit, right? They both are approaching to the same point, but f of a, just difference is not equal and not defined. Difference is not equal and not defined. Not defined. Okay, not defined. Okay, I'll tell you through example. Okay, now let me give you one example. Fx is equal to, if I give you fx is equal to sine x upon x, all right? Sine x upon x. Fx is equal to, I'll give you a lot of examples. X square minus 1 upon x minus 1. Okay, this. You need to check at x is equal to 0. Type of discontinuity. Check at x is equal to 0. Check at x is equal to 0. And third function is this. Fx is equal to tan 2x upon x. X is not equal to 0. And 1 when x is equal to 0. So check at x is equal to 0. Okay. You have 3 examples in this case. Now tell me this thing, the first example. What is the limit of fx when x approaches to 0? Tell me. Left hand limit and right hand limit. Write in the comment box. You're saying no sir, मैं कह रहा था difference between both points सिर्फ not defined and हाँ yes difference between missing and isolated. Yes. Okay, so limit of this function is 1, and what is the value of the function at 0? Can you tell me this value? So as soon as you have got the limit, that means left hand and right hand limit both are equal and finite, that means function is removable. Okay, so you can directly say the function is removable. Now further in the options he might ask whether which type of removable, missing or isolated, he might ask, right? So now we are further trying to find out whether it is missing or isolated. Okay, so that we will get to know after finding f of 0. So if we get the value of f of 0, okay, and which is not equal to this value 1, it is some other finite number, then it will be isolated. And if we are not getting any value at all, that means f of 0 is not defined, then that means it is missing point. All right, so what is f of 0, Raghav? So you can see f of 0, if you put 0 in this, it is going to be sine 0 upon 0. That is 0 upon 0, and 0 upon 0 is not defined, okay? Not defined. So anything divided by 0 is not defined. Similarly, 0 upon 0 is not defined. So f of 0 is not defined, beta, not defined. Okay, not defined. So this is missing point, okay? This is missing point discontinuity. Missing point removable type, okay? Now, why it is called removable? He might ask this question, what should be the value of f of 0 to make this function continuous? What should be the value of f of, because f of 0 is not defined. So you can define f of 0, you can separately define f of 0, like we were defining in this third example. You can see f of 0 is separately, in this example you can see f of 0 is separately defined as 1. So in this question also you can separately define f of 0 as 1, and this function will become continuous. That's why it is called yeah. So what you can do, you can forward this. If there's a lag in video, then you can just fast forward it. Okay, it happens sometimes. In live video you can fast forward, okay? So we'll come to the okay. So what about this second one? What about second one? In this also, can you find the limit when x is approaching to 1? Sorry, not 0, we need to check at 1. Not 0, at 0 it is continuous, okay? It is 0 at 0 it is continuous. There's no problem at 0. You need to check at 1. So what is the limit when x is approaching to 1? It's pretty simple. We're just trying to understand the concept. So you can write x minus 1 into x plus 1 divided by x minus 1. This will get cancelled because x is not equal to 1. X is approaching to 1. It is not 1. So you can't cancel 0, but non-zero you can cancel, okay? In equation or in numerator and denominator. So x minus 1 is not 0. It is approaching to 0, okay? So you can cancel x minus 1. So remaining, you can put x is equal to 1. So answer is going to be 2. So for limit of this function is 2. Okay, so that means it has removable. It has discontinuity, then it will be removable type. Then what is f of 1? Let's find f of 1. So f of 1 is again 1 minus 1 upon 1 minus 1, that is 0 upon 0, and that is not defined again, right? So f of 1 is not defined. So again it has which kind of discontinuity? Missing point. Are you getting this missing point, Raghav? Yeah, it's missing point. If you see the graph of this, then graph of this is y is equal to x plus 1 when x is not equal to 0. So graph of this is like straight line. It's a straight line basically. Only this point is missing. And a third one, a third example, what is the limit when x approaching to 0? X approaching to 0, tan 2x upon x. Okay, write the answer. And f of 0 is given 1. Isolated, yes. So it is 2, right? So limit, left hand limit and right hand limit both are equal and equal to 2. Finite number. And f of 0 is 1. So f of 0 is not equal to left hand limit is equal to right hand limit is equal to 2. This is 1. Alright. So this is isolated. Now you got the difference between isolated and missing point. I think you understood it properly. Good. Okay, I'll tell you. Now, second is non-removable type. Okay, so non-removable, there are three types again. First is jump discontinuity. Second is infinite type discontinuity. And third is oscillating type. The third is oscillating type, like sine 1 upon x oscillates. Okay, so I'll tell you the example. First, let's see jump. So in jump discontinuity, left hand limit should not be equal to right hand limit, but both finite. But both should be finite. I'm telling you the step jump or step discontinuity. Step continuity or discontinuity? Step continuity? Step discontinuity are you talking about, Raghav? So that step means jump discontinuity when left hand limit is not equal to right hand limit. Okay, when left hand limit is not equal to right hand limit, and but both are finite, both will exist. Okay, both will exist finitely, but they will be unequal. Like for example, and value of the function might be anything, doesn't matter. Okay, so we are not concerned about f of a. F of a might be defined, might not be defined. It might be equal to left hand limit, might not be equal to left hand limit, or might be equal to right hand limit. So there's no condition on f of a. Okay, f of a can be anything. So for example, in this you can have one example: y is equal to greatest integer of x. All right, y is equal to greatest integer of x. So greatest integer of x has jump discontinuity at all integers. All right, you can see its left hand limit at x is equal to some integer n. Take any integer, okay, is equal to left hand limit. So its left hand limit is going to be at x is equal to n, so it is going to be n minus h greatest integer. So that is equal to n minus 1. Right hand limit, if you calculate, right hand limit at x is equal to n, so that is going to be n plus h approaching to 0, greatest integer, so that is n. You can see there's a difference of 1, right? Both will exist but unequal. Okay, so there's a value of jump also. Jump value is called mod of right hand limit minus left hand limit. So if you take the difference of left hand limit or right hand limit, left hand limit and right hand limit, then that difference magnitude wise, okay, mod of that is called jump. Like in this case, value of jump is equal to how much? What is the value of jump in this case? What is the value of jump? Yes, there is one. Nice. Good. So value of jump is 1, okay? So if left hand limit, one minute. Alright, so value of jump is 1, very good. Okay. Infinite type, if at least one of left hand limit or right hand limit, okay, approaches to infinity, plus minus, okay, plus minus infinity, then it is called infinite type. type discontinuity. Okay. Like for example, okay, I'll give you y is equal to say 1 upon x when x is more than 0, and x minus 1 when x is less than or equal to 0. Okay, I've defined function like this. So you can see this function, if you plot the graph of this function, then y is equal to x minus 1 line is like this. If I plot the graph, then this is, oh, I'm sorry. Right. It's all right. Is there any problem? Oh, sorry. Okay, I'll do this correction. Minus 1, minus x minus 1. Okay, I'm changing the equation. Doesn't matter. Okay, so now this graph will work. Now this is perfect. This is the graph, left hand before 0, and after 0 it will be 1 upon x. So you can see discontinuity at x is equal to 0. So at x is equal to 0, right hand limit is approaching to plus infinity, you can see, right? And left hand limit is approaching to this point, which is minus 1, and value of the function anyways you don't need to see, because if any one of the limit, left or right, approaches to infinity, then it is infinite type of discontinuity. Doesn't matter what is the value of f of a, and still if you want to check f of 0, then it is going to be minus 1. Okay, so this is infinite type of discontinuity. And oscillating type is when your function oscillates between two numbers. Okay, between two numbers. Like for example, fx is equal to sine 1 upon x. All right, sine 1 upon x. Even if you define this function, at x is equal to 0, say 0, then also this function will be fluctuating, because if you find the left or right limit of this function sine of 1 upon x, then it will be it can be any value between minus 1 and 1, right? So if you know the graph of sine of 1 upon x, then it is something like this. It is fluctuating between minus 1 and 1, right? Like this line. Finally, it goes up like this. It will be less than 1. Anyways, I'm not concerned about the complete graph. It will be like this, okay? And left hand side also, it will be like this, fluctuating. It is very dense. Yes, cos is also cos of 1 upon x, cos of 1 upon x, tan of 1 upon x, okay? All these will be fluctuating. If you put 1 upon x and 1 upon x in any function, like fractional part of 1 upon x, now what will be the value of fractional part of 1 upon x? You can't find. It can be anything between 0 and 1, right? So if you put 1 upon x, then it becomes infinity. Now infinity, your input is like infinity. Input is a very large interval, because infinity is not a fixed point, it's a large interval. So in that interval, that fractional part of 1 upon x will can take any value between 0 and 1, right? So that will be fluctuating. Cos of 1 upon x, sine of 1 upon x, right? Tan of 1 upon x. All these are oscillating functions. So this becomes oscillating around 0 when you put 1 upon x in many functions. In many functions, if you put 1 upon x, then it becomes oscillating. I hope you have got it. But it's not necessary then in all the functions, if you replace x by 1 upon x, then it will be oscillating. Because in tan inverse x, If in tan inverse x, if you put tan inverse of 1 upon x, then for x approaching to 0 plus 1 upon x will be infinity, and tan inverse of infinity is a finite number, right? Pi by 2. So these are three types of non-removable type discontinuity. Okay, so you have two types. One is removable and non-removable. In removable, we further had two types, missing and isolated. In non-removable, we had three types, jump, infinite, and oscillating. All right. In jump, left and right limits will be finite but unequal. In infinite, at least one should be infinite. Both can be infinite. Okay. And in oscillating, it will be oscillating function around that function. Will not have any fixed value. It will be lying in an interval. Can be anything. Okay. So these were the types of discontinuities. Now we will do examples based on this theory in our next session. Okay. So in our next session tomorrow, we'll have examples and further we'll continue other theory part. Okay. All right, Raghav. So I'm ending this session here today. We'll continue tomorrow. You also practice some questions of continuity from your book or booklet, whatever you have. All right. So thank you very much for watching this. Like my videos and subscribe the channel and use my code Jeet1 if you want to subscribe Unacademy Plus. Okay. All right. Thank you very much. Take care. Bye bye. Good night.